An entrepreneur who's producing for profit, he will have an objective to maximize his profit. But at the same time, he will also want to minimize his working capital requirements, minimize the labor skills, reduce the amount of power that he consumes if power is in scarcity. So he would ideally like to have all these objectives to be satisfied at the same time. So basically, but at the same time, he will also want to minimize his working capital requirements, minimize the labor skills, reduce the amount of power that he consumes if power is in scarcity. So he would ideally like to have all these objectives to be satisfied at the same time. So basically, he's dealing with the situation of goal programming with multiple objectives. So goal programming is a variant of linear programming where you have many objectives. So these are the real life problems that we normally come across. And very often these goals tend to conflict with each other. Your requirement of getting higher profit will reduce in more working capital rather than reducing the working capital. And because of this conflict, you need a technique. And therefore, you need to consider which are your hard constraints, which have to be satisfied at any cost, or the soft constraints, which you would like to have ideally. You won't mind. You can also manage without it, but ideally, you would like to, have it. So those are called the soft constraints. So both goal programming and multiple objective linear programming problems can be solved using weighted goals or objective. You can give weights or you can use absolute priorities. What are the actual? You think it's a priority, then you give a number and you can create that priority. So, for a goal programming problem, first you should know what are your decision variables. So, remember, keep that in mind. I should know what are the variables that I'm going to manipulate in order to achieve the goal. Then I should identify which are my soft constraints and which are my hard constraints. And once this is decided, then I develop my objective function, which can be done in many different ways. And then I set it up for solving in Excel and solve it. Now, the goals of a farmer or an industrialist or a businessman or an investor would be to maximize his income. He would also want to reduce the cost of production or the working capital, to the and if labor is a scarcity, he would also want to minimize the use of labor. So, you have all these goals, and that is why linear programming will takes only one objective, and you will not be able to solve the problem. So, to understand, now in goal programming, you will get something called a deviation variable. Now, to understand how the deviation variable works, assuming there are three constraints: working capital, labor, and profit. Okay, we'll call it x1, x2, x3. To each one of these, we will add a positive slack and a negative slack. Positive slack will carry a negative superscript. The negative slack will carry a positive superscript, and that's it. Then you get a value on the right hand side. How this works is, now supposing the x is a variable, it can take any value. Let's assume your final solution of x is 7. Now for 7 to be equal to 5, 7 is more than 5. For 7 to be equal to 5, this minus d1 should take a value 2. So this minus slack gets activated when this target is overachieved. Now take another example. Now this x2, which is labor, is 10. Now let's assume that your value that you get for x2 is 5. So 5 to be equal to 10, the positive slack should take a value 5, in order to make it. So whenever a target is underachieved, the positive slack variable takes a value. Supposing a value has to be equal to 15 and x3 is equal to 15, then both d1 and d3 take 0 values. So d1 and d2 can either take a positive or a negative value, but both will not have values, only one will have values. So this is a typical formulation of a deviation variable. So 400x1 plus 750x2 plus 1050x3 plus d4 minus d4 with a positive superscript equal to 25. Now let's assume that this should be greater than 25. So I want this. So it's a soft constraint. I want 25. Anything more than that will be great. I want greater than 25. In order to make it greater than 25, this deviation should take a value, like I demonstrated over here, and this deviation should be 0. So what I will do in my objective function when I do word programming, I will make this, I'll minimize this and not this. Because this I want to maximize. Alternatively, let's assume that 18,000 x1 plus 33,000 x2 plus 45,150 x3 should be less than 1 million. Then, in which case, this should be equal to 0. It should be less than 1 million. This should take a value, this should become 0, and I will target this. So, in my objective function, I will minimize this. I will minimize this and this. So, that's how whole programming is done. So, let me show you an example. This is a typical farming example. You have decision variables. It can be anything. It can be just anything. It can be stocks. It can be products in industry and things like that. So this, in my case, ragi, paddy, ragi, groundnut up to dairy. The cost coefficients gives me the profit per acre, 17,850, 12,750, so on and so forth, 23,000 from dairy. Then I have constraints, 111, 11 like this, and then I say this is that means these in rain-fed areas you can grow ragi, groundnut, maize, sunflower, and tur. You cannot grow paddy, so therefore it's black. So paddy can be grown in irrigated land. So put a 1 year, and vegetables can be grown in irrigated land. I'll also put a 1 year. But when it comes to garden land is essentially defined as land which is used for which is cultivated using borewell water. So what I will do is garden land I will be can be cultivated. So I put a 1 over here. And then here what I will give is rainfed land 1.47 acres, irrigated land 0.75 acres, and garden land 0.3 acres. Right? So all these three should be less than. Now these are hard constraints, rigid constraints. I have to satisfy. I don't have more land, I cannot exceed. Then I have got capital. I have this is okay, these are constraints, but I'm not targeting them. This labor I will target because labor is a soft constraint. It's a hard constraint because I have only 241, but I relaxed it using higher labor. And so it's a soft constraint because I can hire. But when it comes to capital, I've reduced it. When it comes to capital, it is it's a hard constraint. I've got only 1.5 lakhs. In the example, it's a little less. And farmyard manure, you will notice whenever I give farmyard manure is produced by dairy, it is consumed by crops. Therefore, one will have a negative sign. The producer will have one sign, the consumer will have the other. It doesn't matter which. Similarly, when it comes to fodder, the crops produce the fodder, it is consumed by dairy, so it has the different signs. So it doesn't matter what sign you give except that one set of signs should be negative and the other set of signs should be positive. Here again, it depends on whether you're going to you're expecting this to be greater than or less than. Appropriately, you should put this. You should put these inequalities. Because we expect the positives to be greater than the negatives, greater than. If the negative is going to be greater than the positive, then you should put less. That of course you can modify as you go. When it comes to ragi, he needs a minimum of 1 quintal. So the coefficient you put is the yield per 1 acre of ragi because all this is in acres. This is per cow. Okay, and for milk, you should give what is the production of milk in one season. Sorry, in one season that is 120 days, and how much is the milk that he wants? 60. This is what we normally do for intercropping. I say for every 6 rows of ragi, you should have 1 row of groundnut in order to enrich the soil. Similarly, in production, you will have production which are produced as joint products. In milk, you can find out that butter and buttermilk are produced together. Similarly, here you say for every 6 rows of ragi, you should have 1 row of groundnut. So then, when I put the coefficient, I should reverse it. So it's not 6 and 1, it is 1 and 6. One should carry a negative sign, and the inequality should be made equal to 0. Equal to 0. If you want to see how this is done, this is how it's formulated in a solver. So you can just pause it and see how these equations are done. You can see that the objective function is this row, that is row 2 multiplied by row 3. Constraints are that constraint row multiplied by row 3. So row 3, you can see B3, J3 is common for all. So every row is multiplied. That row is multiplied by the changing cells row. And that is how the linear programming problem is formulated. Now we will go straight into the problem and see what it looks like. Okay. So for the time being, I'll take out this and you'll see how it is being formulated. Okay, it's the same thing that we discussed. Here what I do is I am targeting this thing. I'll first maximize. I am targeting, this is my objective function, this is my objective. I'm trying to, this is linear programming. I want to maximize my profit. I want to maximize my profit. Yeah, I want to maximize my profit. I've shown you this in an earlier slide. My objectives are related to profit. It's related to labor. I want to minimize the labor use. And I also want to minimize the capital. So I set up the linear programming problem. I go to solver. Then this is my objective function. These are my changing sets. It's a maximization problem, and these are my constraints. This you've seen it earlier. Simplex, and I solve it. It says solver found a solution. All constraints and optimality conditions are satisfied. I will not go much into it. And I know that I can make a profit of 26,620. And what will I do? What will I do? What will I do? I will use, this will be my production plan. This will be my production plan. 0.232 acres of paddy, 0.036 of ragi, 0.06 of groundnut, 1.4 of maize. I'll hire 276 labor, and then I will grow 0.3 acres of vegetables and I have half a cow. So I see that all my land is utilized. Irrigated land is not fully utilized, only 5.53 acres or 0.75. All my garden land is occupied. So this plan, I will place it here. This is my output. Then I try to maximize my profit. Now I'm going to goal programming. So when I go to goal programming, when I convert a linear programming problem into goal programming, first I will take my objective function, because that is one of my objectives. Make it a constraint. Make it a constraint. Because I've taken it and put it in the bottom. So now this is a goal program. This is what I do. Then for every objective constraint which I'm going to use in my goal programming, I should put 2 deviation variables as I showed. So since I've got 3 objectives, I should have 6. I should have 6 deviation variables in this fashion. So I'll have +1 and a -1. And another +1 and another -1 for, and another +1 and a -1. Wherever the constraints are, earlier this was less than. So I should make it also equal to. Okay, and we'll close it. And before I go, I should make this equal to start. So I'm saying critically. So here what I do is, okay, this is a soft constraint. This is a soft constraint because I can hire. I say it should be less than 245. So to be less than 245, this value, this variable should take a value. This variable should be minimized. So here I will put D1, D2, D2, D3, D4, D3, and D6. Okay. Now this variable has been, this less than means the positive slack will work. So here I should put what I want to minimize this. I want to make this 0. When it comes to working capital, I want this to be minimized. So this I want, this I want. I want this to take a value and this should be minimized. So I put it over there. When it comes to income, I want the negative one to be, because negative is overachieved. So I don't mind if the income goes over 23,000. So I'll minimize, I want this. So here I'll minimize the one. I don't want D5. I want the negative, because the negative tells me by how much it will overachieve. So once this has been set up, then what I have to do is I'll have to extend this. I'll have to extend the problem, because now the problem has been augmented because of the slack variables. Because of the slack variables for some activities, not all, but all have to be extended. So I'll just do it one at a time so that you will know what I'm doing, and you will also remember to do it when you are formulating it. So that was. If I do this, that one, and I'll extend this also here. So these I'll do because you've got a different color. Since this is fixed, these two I can just drag down. This one has to be extended as well. So since these are all okay, I can just bring it here. And this one I have to do. Also, it doesn't have formula. So to drag the formula here. So this one I can give the formula. So okay, fine. So it is done. So now we have, this is what all you have to do. You should carefully select which variables you want depending on what the goals are. And of course, we'll see everything is set. Now I'll just go to data, solver, and it will be a minimization. You should not forget, it should be a minimization. Changing cells have to be extended or two, because that's done in the program. The other things have already been done. Make sure it's an LP, solve it. Solver found a solution, all constraints and optimality conditions are satisfied. You say okay. Okay. Now you notice, now the cropping pattern has changed. So when ultimately this is your interest, you're not interested in all that. You want to see what should I grow when I satisfy all my objectives. It is paddy should be increased, honey should be increased, groundnut should be increased, maize should be done away with, hired labor because you targeted it. You said minimize my labor. Now labor has decreased from 276.99 to 155.19. Okay. And dairy of course. So changes have taken place. And you notice that unfortunately for you, your working capital has not decreased. So what now the two slack variables associated with working capital is this is for working capital. Working capital. You were interested in underachievement. Sorry, so this should be one. I made a mistake. This should be one, not this. Okay. So here the positive should take a value. Here, here also, you want the positive to take a value. That's a really mistake. You don't want the negative to take the value. My mistake. Sorry. Okay. Here you want the positive coefficient to take the value. Only then it will underachieve. Because the negative overachieves. Here also you want the positive value to take a value. Here you want the negative to take a value. So it should not be this. It should be. I will now show you how this, because when the problem becomes very large, because linear programming problems, when you use it in practice, is much larger than this. And very often Excel will not be able to solve it. So I will now show you how linear programming problems are solved in Python. So we continue. And what we do is the figure that we put over here is the maximum that we've got when we optimize. So when you do an optimization, you do an optimization, or you go to data, and you go to solver, and you solve. It's already been set up, so we solve. We get a solution. So the maximum that you get will be maximum that you can get without any constraints is 26,230. That's the figure you're going to put over here, 26,320.65. So you relax it later with this thing, and we'll put it as equals. Okay, this objective function, when we do goal programming, it gets converted as a constraint, which we then call income. And these coefficients will be removed. these coefficients will be removed. Then for each of the targets that we're going to target, first we want to minimize this, we want to minimize this, and we also want to maximize this. So that's why we are doing the goal programming. So we'll have to create two slack variables for each goal. So since you've got 3 goals, you should have 6 slack variables. So 2, 4, 6. So I insert blanks, right? And then I create a slack variable. One will be positive and the other one will be negative. Similarly for this, one will be positive and the other one will be negative, which I showed you in the earlier example. Similarly for the third one will be positive, the other. And as we know, the negative will capture the overachievement, positive will capture the underachievement. Then we'll name them in the objective function. We'll call it D1, D2, D3, D4, D5, and D6. Okay. Now we are getting coefficients. Now the objective here is to minimize. It is to minimize. It's a soft constraints because you've allowed borrowing. And right now you are hiring 276.77 mandate. I'll just copy this down for the time being. I'll just copy it down and keep it over here. And I also write the profit figure. I mean, these were all these variables. For each of the decision variables, these are the current levels when you get a profit of 26,320. So I call it profit. So it will be 26,320.65 is the profit that you get per season, right? Then we've created these slack variables. Then now this slack variable, we want it less than 245. So now you have 2 slack variable. You want this labor to be less than 245. You've got 2 slack variable. This captures underachievement. This captures overachievement. You want a value for this and you don't want this, and therefore you minimize this. That's the logic. Similarly for working capital, right now you've got 30,000. This will achieve underachievement. This will achieve overachievement. You want working capital to be below 30. That means you want this positive one to be activated. So we minimize this. We don't want this. We want this to be ideally 0. Similarly, when it comes to income, we want an income greater than 26,000. We want an income greater than 26,000. So therefore, we are interested in this value, to take a value. This we do not want, and we minimize this. This we put it as well. Now we've created the slack. And we've also created the appropriate coefficients in the objective function. The original coefficients, since they've been converted to income, we can delete it. We don't need it. So we'll have only this in the objective function, which you then minimize, right? So this is how we set it up. So whenever we create these slack variables, these inequalities, you make them equalities. Whenever you have it. So your inequalities will not be, your inequalities in the linear programming equation will be converted to equations now. They're all equations because there's no inequality. They're all equal to. And that is how the goal programming is set. So you should pay careful attention to this. And then we are going to solve it. Okay, so roughly again to see it once again. This is 20.6 for me. Yes, it's just rounded it out. So it's 20.65. So we set that all the coefficients are. I just go to formulas and just check the precedence. So it's all okay. I just have to see whether these have all been properly formulated. Yeah, absolutely. Somewhere in the middle also. So these have been formulated properly. Great. So I'm going to remove it. Remove the errors. So now it's all set. And now I'll just solve it. And that is what will give me the result. So I'll go to data, solver. And then now it becomes a minimization. It's no longer a maximization. This is my objective function. It's in the right place. These are my changing cells. Okay, this is done. So I can just check the changing cells. Changing cells are also in place. So changing cells. You can see it is from B3 to P3. Right? Then all the constraints, I just have to check this constraint in row 8. Constraint in row 8 should be equal to, constraint in row 9 should be equal to, and constraint in row 17 should also be an equal to. The others, of course, don't matter so much. So I will check its linear program and solve it. So I go to data, I go to solver, and I press solve, and I get the optimum values. I get the optimum values. So this is 25,000, not 30. Mistake. And I've solved it using solver. Everything is set. So these two are labor, and this should also be equal to, right? Equal to. And now the solution has been found and the goal programming is over. So what the goal programming says is you will still achieve an income. Your income is not reduced. It is 26,320, which you targeted. There's no reduction. How you read it is now here. Okay. And this is my new decision variable. So I just copy this down. I'll copy this down and I'll paste it. So this is my new one. Okay. Income is not changed. It remains the same. 26,320.65. 26, 26, 26, 320.65. Okay, that's a change. Now let us look. Working capital is 25,000, not 30, 25,000. Okay. Capital, not capital, working capital. Then we will put labor here. Labor. Labor is totally, now labor, it is hired so much. It is hired so much, plus it has so much, 22, 25 you have. So total labor used without any constraint is 522. Now labor use becomes, hired labor has become 0, no labor has been hired. And what you should read of is the slack of the labor. Okay, so labor has now become 0. So there is no labor at all. There is no labor hired at all. So now your labor has become just 245. 245. Income has not changed. Now when you look at working capital. Now these are the two slack variables associated with working capital. Now the positive slack has taken a value. When the positive slack takes a value, it will underachieve the target by so much. So your working capital, which was 25,000, now becomes 25,000 minus the positive slack, because that is underachievement. So your working capital has now reduced to 14,868. And this is what goal programming does. So I've just showed you a linear programming solution of the goal programming, and this is what goal programming. So we start with this. We've already created. We started it, then we created the objectives to the system. Okay, and we have solved it using goal programming, and the result then finally tells us paddy has gone out, ragi has remained the same, groundnut has remained the same, maize has been completely replaced. Labor, which was 265, hired labor has become 0 because you minimized it. Sunflower area, which was 0, has now become 0.44. Vegetables remains the same. Dairy from 0.56 animals has come to 0.27. And you get the same profit. Your profit has not changed. Only effectively you have reduced the labor hiring and working capital as well.